Welcome. Today we'll test the convergence of an infinite series using both the alternating series test and the absolute convergence test. Let's first understand what happens when we evaluate cosine of n pi. When n is 1, cosine of pi is -1. When n is 2, cosine of 2 pi is 1. When n is 3, cosine of 3 pi is -1. And this pattern continues, alternating between 1 and -1. Therefore, we can rewrite our series as an alternating series. The series becomes -1 over n to the 3/4 when n is odd, and positive 1 over n to the 3/4 when n is even. To use the alternating series test, we need to check two conditions. First, the terms without the alternating signs must decrease monotonically. Second, the limit of these terms as n approaches infinity must equal 0. Let's check the first condition. The derivative of 1 over n to the 3/4 with respect to n is -3/4 times n to the -7/4. Since this derivative is always negative for positive n, the terms decrease monotonically. For the second condition, let's take the limit as n approaches infinity. The limit of 1 over n to the 3/4 equals 0 as n approaches infinity, since 3/4 is positive. Since both conditions are satisfied by the alternating series test, our series converges conditionally. Now let's check for absolute convergence. We need to test if the series of absolute values converges. That is, we test the convergence of the sum of 1 over n to the 3/4. We can use the p-series test. For a p-series, if p is greater than 1, the series converges. If p is less than or equal to 1, the series diverges. In our case, p equals 3/4, which is less than 1. Therefore, the series of absolute values diverges, which means our original series is not absolutely convergent. Combined with our earlier result, we can conclude that the series converges conditionally but not absolutely.